Most people think ship anchors work like giant grappling hooks. You drop them, they grab the seabed, the ship stops. Simple, right? Not even close. In reality, an anchor alone can't hold a massive cargo ship in place. What really keeps thousands of tons of steel from drifting away isn't just the anchor. It's physics, chain weight, and something called the catenary curve. And once you understand how it actually works, you'll never look at anchors the same way again. Here's the biggest myth about ship anchors. People imagine them like giant hooks grabbing onto rocks at the bottom of the ocean. Movies make it look dramatic. The anchor drops, it catches something solid, and the ship instantly stops. But that's not how it works. In fact, if an anchor simply hooked onto a rock, that would be dangerous. Rocks don't provide stable holding power. They create unpredictable grip points. A sudden shift in wind or current could snap the chain or dislodge the anchor completely. Modern anchors aren't designed to hook at all. They're designed to dig. They work more like a shovel than a hook, burying themselves into mud or sand under tension. And here's the surprising part. Without the heavy chain lying on the seabed, even the best anchor would fail. The anchor alone doesn't hold the ship. The system does. When a ship drops anchor, the chain does not form a straight line. It forms a natural curve due to gravity. That curve is called the catenary curve. It's the same shape you see in hanging power lines. The mathematical form of this curve is: this curve matters because the weight of the chain absorbs shock from wind, waves, and current. Instead of the anchor taking the full force of the ocean, the chain acts like a massive shock absorber. If wind increases, the curve slowly straightens, increasing tension gradually instead of creating violent jerks. That's why ships release chains several times longer than the water depth. It's not just length, it's physics. Ships cannot anchor in deep ocean. Why? Because anchoring depends on the chain lying along the seabed. If the water is too deep, the chain would hang almost vertically. That removes the horizontal force, and the anchor would drag. That's why anchoring usually happens in ports, bays, and coastal waters. In deep sea, ships rely on engines and dynamic positioning systems instead. Sailors measure anchor chain using something called a shot. One shot equals about 90 feet, roughly 27 meters. Each section is marked with color codes. The key concept is scope, the ratio between water depth and chain length. A common scope is 5 to 7 times the depth. Too little scope, and the anchor may drag. Too much, and the ship may swing dangerously. There's another factor people rarely think about: suction. When an anchor buries itself into mud, it doesn't just rely on friction. Wet seabed creates a vacuum-like resistance. The deeper the flukes dig, the stronger the suction effect becomes. In some cases, the holding force can be several times the weight of the anchor itself. That's why large commercial anchors may weigh 20 tons, but can resist forces far beyond that. Engineers calculate holding power based on seabed type, anchor design, and scope ratio. It's not guesswork, it's marine engineering. If you enjoy discovering how things really work, subscribe to Everyday Decoded. New smart explanations every week. And here's something even more surprising. Modern ships often use 2 anchors for stability. In strong wind conditions, vessels may deploy anchors at an angle, creating a wider holding pattern. This reduces swinging and distributes tension more evenly. Large ships also perform regular anchor tests to ensure the system works before entering busy ports. Because when thousands of tons are floating in open water, failure isn't an option. Anchoring isn't primitive. It's one of the most refined systems in maritime engineering.